Today we will discuss about partial differentiation. So partial differentiation. So we have discussed ordinary differentiation. So here we discuss about the partial differentiation. Partial differentiation, we have more than one independent variable. Two or more than two independent variables we will discuss here. So we write down the partial derivative. The partial derivative of z is equal to function of xy. Okay, so here we consider two independent variable x and y and z with the dependent variable. So z work as a dependent variable and x and y be the independent variable. Is defined as del z upon del x. So the operator del, so this operator del is used when we are doing partial differentiation. Partial differentiation of z with respect to independent variable x. So when we are obtaining del z upon del x, so here we treat another independent variable, that means y, as a constant. Treat another independent variable as a constant. Similarly, we are going to calculate del z upon del y. So here we write treat x as a constant. Similarly, we do the second derivative. So second derivative, we write down as del square z upon del x square. So we do same thing. That means we treat y as a constant, and here we calculate del square z upon del y square with respect to y, and second derivative we have another term, that is del square z upon del x into del y. So this is always equal to del square z upon del y into del x. So this value is equal to del square z upon del x del y equal to del square z upon del y del x. So when we are obtaining first derivative with respect to x, we treat y as a constant, del upon del x, and similarly we are going to calculate del z upon del y, we treat x as a constant. So we have a function z is equal to fxy. So we define the partial derivative of z with respect to x and y. So we obtaining del z upon del x and to del z upon del y. So we take one example. So how to calculate this? So that means we have an example. If we have the function z equal to x square into sine y, x square into sine y. So when we are going to obtain del z upon del x, so this del z upon del x, so we calculate as we differentiate partially with respect to x, treat y as a constant. So differentiation, this term purely belongs to x. So we do the differentiation of x square as per normal formula, that means ordinary formula. So the differentiation of x square is 2x and treat y as a constant. So second term belongs to purely for y. So we write into sine y as it is. Okay. So similarly, we do for del z upon del y. So when we are going to differentiate partially with respect to y, so we treat first term as a constant purely. So x square we treat as a constant, and differentiation of sine y, the differentiation of sine y equal to cos y. Now, further differentiation of these, that means we are going to calculate del square z upon del x square. So del square z upon del x square, this gives us, so the differentiation of 2x. Okay, so this gives us 2 into sine y we treat as a constant. And similarly, we are going to calculate del square z upon del y square. So we differentiate again this term with respect to y partially. So we see that, so this having x square and differentiation of cos y is minus sin y. So this can be written as minus x square into sin y. Okay, so when we verify our answer, that means we have written that del square z upon del x del y is equal to del square z upon del y del x. So first we obtain the value of del square z upon del x del y. So this can be written as del upon del x into del z upon del y. So we have obtained del up z upon del y already. So the value of del z upon del y, this value we put here, x square into cos y. So we differentiate partially this with respect to x. So this gives us 2x into cos y. We treat y as a constant. So del square z upon del x del y, we have a 2x into cos y. So this is del square z upon del x into del y. Again, we obtain the value of del square z upon del y into del x. So this we can write as del into del y upon del z into del z upon del x. So this gives us del upon del y. The value of del z upon del x we have calculated in first step. This gives us 2x into sin y. So 2x into sin y. So when we obtain the partial derivative of this function, so this gives us 2x into cos y. So 2x we treat as a constant and differentiation of sin y equal to cos y. So we see that this term is equal to this term. So hence we can say that means del square z upon del x del y is equal to del square z upon del y del x. So we write down that hence del square z upon del x into del y is equal to del square z upon del y into del x. Okay, so hope you understand the partial derivative. So this purely related to the function of two variables. We have z equal to function of xy. Similarly, we have a function of three variables. So suppose let us u, we introduce the dependent variable as u. So u equal to function of x, y, and z of three independent variable. So u is the function of three independent variable x, y, and z. So we calculate. So we calculate del u upon del x. So while calculating del u upon del x, we treat y and z as a constant. So our working variable is x. So we treat y and z as a constant. Similarly, when we obtain del z upon del y, del u upon del y, so we obtain del u upon del y. So we treat x and z as a constant. And we are obtaining del u upon del z. So we treat x and y as a constant. Okay, so similarly, we can do for the second derivative, third derivative, and so on by remembering these steps. That means when we are going to differentiate partially with respect to x, so we treat y and z as a constant. We are going to differentiate partially with respect to y, we treat x and z as a constant. And we are going to differentiate partially with respect to z, so we treat x and y as a constant. So now we take one example related to that. So suppose we have the function, we have u is equal to e raised to the power x, y, z. U equal to e raised to the power x, y, z. So we find the value of del QU upon del X, del Y, and del Z. So here we obtain the value of del QU upon del X, del Y, del Z. So basically we start with del U upon del Z. So first we start with del U upon del Z, then we take the derivative of del U upon del Z with respect to Y, and then we have to calculate this one. So we take the derivative of that function with respect to X. So now we write this as del upon del X into del upon del Y into del U upon del Z. So basically we follow this thing. So first we obtain del U upon del Z, then we differentiate that function with respect to Y and then with respect to X. So this is our equation 1, or when we write this as U is equal to e raised to the power X, Y, Z. Okay, so when we differentiate this partially, so we write down as differentiate 1 partially. So this with respect to Z. So here we are going to differentiate equation 1 with respect to Z partially. So that means partially means we treat X and Y as a constant. So we treat X and Y as a constant. So the derivative of U with respect to Z denoted as del U upon del Z. So when we treat X and Y as a constant, so we use the formula. Suppose you have e raised to the power ax. Okay. So when we calculate du upon dx, so this gives us a e raised to the power ax. So similarly, we are going to partially differentiate with respect to Z. So we treat Z as a variable and xy as a constant. So xy work as a. So this gives us x y into e raised to the power x y z. So this is the derivative of equation 1 with respect to z partially. So now again differentiate to partially with respect to y. So when we differentiate 2 with respect to y, so this can be written as del upon del y into del u upon del z. So this thing we can write as del square u upon del y del z. So this equal to, so this can be written del upon del y into xy e raised to the power xyz. So here we see that there is two function. So there are two function of y. First y is here and second is here. So we use the product rule for differentiating partially. So this we can write down as, so this is our first function. So we write down first function as it is and derivative of the second function. So the derivative of second function with respect to y. So we treat x and z as a constant. So we write down as xz into e raised to the power xyz plus differentiation of first with respect to y. So this gives us x and the second as it is. So we write down as xyz. So this gives us, we write down as x square into yz e raised to the power xyz plus x e raised to the power xyz. So this is the value of del square u upon del y into del z. Now again differentiate. So this we write as equation number 3. So again differentiate equation 3 partially with respect to x. So this can be written as del upon del x into del square u upon del y del z. So this thing we write down as del qu upon del x del y del z is equal to del upon del x into x square yz e raised to the power xyz plus x into e raised to the power xyz. So we see that there are two functions of x. One is this, second is this, and same in second term. So there are two function of x. So now we use the product rule here also. So when we take the first term, so that means we write the first function as it is, x square into yz into differentiation of second term with respect to x. So we treat y and z as a constant. So we write y into z and differentiation of x, y, z, e raised to the power x, y, z is e raised to the power a e raised to the power, that means we have the formula. So we do the same. Okay, so plus differentiation of first term. So here we have x square. So differentiation of x square is 2x, and y z we write as it is, and second term remains same. Plus we write the first term as it is, and differentiation of second with respect to x, we treat y and z as a constant, and differentiation of this will be e raised to the power x by z. Plus differentiation of x is 1, and we write second term as it is. So this we can simplify as, so we write down as x square, y square, z square, e raised to the power x, y, z plus, so 2xyz plus xyz. So this gives us 3xyz e raised to the power xyz, or plus e raised to the power xyz. So we can take e raised to the power xyz as common. So this we can write as x square, y square, z square plus 3xyz plus 1. So this is the value of del QU upon del x, del y, del z. So this is our answer. Hope you understand this topic.